Right. Good day again. Today's session would be on optimization of economic functions. Okay, in one of our previous chapters, we look at the turning points and the nonlinear functions, right? And then we find it to be where the derivative is equal to 0. That is where f prime at x is equal to 0. We then determine the nature of our turning point using the second derivative test. Like we said, if f prime prime at x star is greater than 0, then this means we have a minimum point. Meaning our turning point is a minimum point, is a minimum turning point. And then we said if f prime prime of x star is less than 0, then this means we have a maximum point. Okay, in this chapter, we'll apply this information to our functions. Like we will apply this information to our functions such as like total revenue, total cost, and profit function. Okay, this means we'll be maximizing the total revenue and the profit, or minimizing the total cost. Okay. Okay, let's do an example here. Suppose we are given, okay, each one. Suppose you are given a demand function for a good as P equals 300 minus 6Q. Okay, this is our demand function. Here, P represents the price per unit and Q represents the number of units produced and sold. Okay, remember I said we are applying this information to our equations, and you know our equations are the total revenue, the profits, total cost. So here, suppose we are trying to maximize the total revenue. Okay, we are given the demand function, and we know that the total revenue is equal to the price per unit times the number of units, meaning the total revenue is equal to P times Q, and we are given our P as 300 minus 6Q. So we have this Q. If you simplify this bracket, you'll say Q times 300 and then Q times this minus 6Q. And if you do that, you should find 300 minus 6Q. So this is our total revenue, right? Okay. We have our total revenue. We are trying to maximize the total revenue. We said we need to find the turning point, like, because the turning point that should be where our total revenue is at minimum or at maximum. So we need to find the minimum point on our total revenue, and we said we will find that point by finding the derivative and equate it to 0. Okay. We need to find the derivative of this. And we know that the first derivative of the total revenue, that is the marginal revenue. So this means we need to find the marginal revenue. Okay, we know that's from our previous section, we said marginal revenue is equal to the first derivative of the total revenue. Okay, and our total revenue is 300 minus 6Q. 300 minus 6Q. So we need, okay, we have squared here and we have Q because we have 300 times Q is 300 Q, and we have minus 6Q times Q, that gives us minus 6Q squared. So if we differentiate this, okay, we said this is Q, 6 squared Q. If we differentiate this, you should get 300 minus 12Q. So this is our marginal revenue, right? Okay. Our aim wasn't to find the marginal revenue, but we wanted to find the point where the turning point, and we said we'll find the turning point by finding the first derivative and equating it to 0. Our first derivative is the marginal revenue in this case. So this means we need to equate our marginal revenue to 0 and solve for our point. Okay. And if we do that, say MR is equal to 300 minus 12Q equal to 0. Okay, this means we have 300 minus 12Q equal to 0. We need to make Q a subset of a formula. To do that, I will transpose Q to the other side and be left with 300 on another side. And if I do that, I will have 12Q equals plus 300. Right? I'm transposing minus 12Q to the other side. And if I transpose minus 12Q to the other side, it changes the sign. It's from negative to positive. That's why we have plus 12Q. Okay. Remember, the aim is to make Q the subject of the formula. So we don't want 12Q, we need Q. So to get rid of 12, we need to divide, well, 12 on both sides. And if we do that, you should get Q equals 25. Okay. Now we have Q equals 25. This is our turning point. This is our turning point. Okay. Now the next step is to use the 25 and the second derivative test to find the nature of this turning point. Okay. We have a turning point. The turning point at Q equals 25. We need to find the nature of this point. We need to determine whether this is a maximum point or a minimum point. And to do that, we use the second derivative test. Remember? Okay, let's go back. I said in our previous class, we first find the turning point by finding the derivative and equating to 0. And we obtain X star. And then to check whether X star is the minimum point or maximum point, we find the second derivative and we substitute that X. If the second derivative is greater than 0, then we have a minimum point. If the second derivative is less than 0, then that means we have the maximum point. Okay, our first derivative is our marginal revenue, which is 300 minus 12Q. Okay, remember, this is the first derivative, like TR prime, right? We need to find the second derivative, TR prime at Q. Okay, this means to find the second derivative, we need to differentiate the marginal revenue. And we know that the marginal revenue is the derivative of is equal to the first derivative of the total revenue. So we are differentiating the first derivative of the total revenue with respect to Q. And we know that the first derivative of the total revenue is equal to 300 minus 12Q. So this means we are differentiating 300 minus 12Q with respect to Q. If we differentiate this, the derivative of 300 is 0, and then the derivative of minus 12Q is minus 12. Minus 12. So we have our second derivative in minus 12. Then the next part is to substitute our turning point on the second derivative and check the sign of the second derivative. Okay. Our point, the turning point is 25. If we substitute 25 into 12, okay, this is just a constant. That means we'll obtain minus 12 again. Okay, the second derivative is less than 0, right? It's less than 0. If the second derivative is less than 0, that means we have a maximum point. Okay, we have a maximum point at Q equal to 25. Okay. Remember, we're trying to find the maximum total revenue. Now we know that the total revenue, we know that we have a maximum total revenue when Q is equal to 25. Then the next step is to find the exact amount on the total revenue. Okay, we know that the total revenue, our total revenue is equal to 300Q minus 6Q squared, right? Now we need to find the total revenue of 25. So this means we have 300 times 25 minus 6 times 25 all squared. This means we have 750 minus, 7,500 minus, okay, this will give us 3750. And if you punch this in your calculator, you should get 3,750. Okay, this means when 25 units are sold, the total revenue will be, okay, the total revenue is a maximum of 3,750. Okay, let's do another example. Example 2. Okay, now suppose that we are told that the output over time for a firm is given as Q at T equals T cubed over 3 minus 5 over 2 T squared plus 6T plus 100. Okay, we are given this. This is the output over time for any firm. Okay, for just a specific firm. And then here we are told that T is measured in years and Q is the output in hundreds of units produced. Okay, now we need to determine the years when the output is a maximum and when the output is the minimum. That is, we need to find the turning point of Q. And then after finding the turning point of Q, we need to find the second derivative of Q and check which of the point gives the minimum output and which of the point give the maximum output. Okay, we have Q equal to this, right? I said we need to find the turning point, and we will find the turning point by finding the first derivative of Q and equate it to 0, right? Okay, let's find the first derivative of Q. We have T cubed over 3. If we differentiate T cubed over 3, you should get t squared, and we have to differentiate 5 over 2 t squared. If you differentiate that, you will find minus 5t. The derivative of 60 is just 6. The derivative of 100 is 0. Ne? Then the next step, you equate this derivative to 0, then you solve. Okay, we need to okay, this is our first derivative. If we let this derivative to be 0, we will have t squared minus 5t plus 6 equals to 0, right? And if we factorize this, you should get t and t, 3 and 2 minus and minus, okay? So this simply means we have a turning point. Okay, Q has a turning point at t equals to 3 and t equals to 2. So this is our turning point. Okay, the next, you can find the corresponding point, the corresponding value that correspond with t equals 3 and t equals to 2. Let's try and find them. T at 3. T 3 will give us, okay, we are substituting back to the equation of Q, right? And if you punch this in your calculator, you should get 104.5, right? Okay, this means we have a point 2. Okay, this is 3. 3 is 2, 104.5. Again, we substitute 2 at 3 in our Q. If we do that, we should get 2. Okay, this is cubed over 3 minus 5 over 2 times 2 squared plus 6 times 2 plus 100. Again, if you punch this in your calculator, you should get 104.7. This means we have a 0.2 is to 104.7. Okay, this is our second point. And then we need, remember, they said we should, after finding our turning point, the next step is to determine whether those turning points are minimum points or the maximum point. And to do that, we need to use a second derivative test, right? That means we need to find the second derivative of Q. Okay, we said the first derivative of Q is t squared minus 5t plus 6. To find the second derivative of t, we need to differentiate the first derivative of Q. Okay, meaning we need to differentiate t squared minus 5t plus 6 with respect to t. Okay, if we differentiate t squared, you will get 2t. We differentiate minus 5t, you'll get minus 5. You'll differentiate 6. 6 is a constant. The derivative of a constant is 0. So this means our second derivative is 2t minus 5. Then the next step is to substitute our points, our turning points on our second derivative and check the sign. Okay, let's first substitute. Okay, this is our second derivative, 2t minus 5. Let's first substitute 2. If you substitute 2, you'll have 2 times 2 minus 5. And this will give us minus 1. And this is less than 0, right? This is less than 0. Okay, this indicates that the maximum, we have a maximum turning point at, okay, maximum at t equals to 2. Okay, now let's let t to be 3. because our second turning point is 3. So this means we have q prime prime of 3, which gives us 2 times 3 minus 5. This will give you 1, and 1 is greater than 0. Since at t is equal to 3, our second derivative is positive, meaning it's greater than 0. This indicates that we have a minimum turning point at t equals 3. So say minimum at t equals 3, right? So you can say the output will give a minimum at a year 2, and it will give a maximum at a year 3. Okay, let's do one more example. Okay. Example 3. Suppose in example 3, we are given that a demand and the total function for a firm is given by, okay, a demand is 100 minus 4Q, and the total cost is given as 320 plus 4Q. Okay. From this information, from what we've been doing so far, like in even on our previous classes, from this information, you can find a break even. You can determine where the profit will be made. You can determine where the loss will be made, right? Okay, first, to do those, let's find the total revenue. Okay, first, we know that at break even, the total revenue is equal to the total cost, right? When the profit is made, the profit can only be made when the total revenue is greater than the total cost, and the company will have a loss when the total cost is greater than the total revenue. Okay, let's find the break-even points. Okay, we are given the demand function and the total cost, meaning we need to find the total revenue first. Total revenue, okay, this is P times Q, and we know that our P is 100 minus 4Q times Q. And if you do this, the simplify, you'll have 100Q minus 4Q squared. Remember, I said at break even, that it's only occurs whereby the total revenue is equal to the total cost. So we can use this at break even. Total revenue is equal to the total cost. We know that the total revenue is 100Q minus 4Q squared, and the total cost is given as 320 plus 4Q, right? 320 plus 4Q. We need to find our points, our Q, and those points will only occur at the break even. Okay, we'll determine the break even. Those would be the break even points. Okay, I will transpose these to this side. Okay, if I do that, I will have minus 4Q squared plus 100Q minus 320 minus 4Q. Okay, the next step is to collect the like terms. We drop the like terms. If we do that, you should get minus 4Q squared, 100Q and minus 4Q. That will give us plus 99Q, and we have 320 equal to 0. You see, we have a common factor of minus 4, so I'm just going to divide all our terms with minus 4. Okay, if I divide this term with minus 4, I will have Q squared. If I divide this term with minus 4, I will have minus 24Q. And if I divide this term with -4, I will have plus 80 equal to 0. Okay. The next step is to factorize. Remember, I said if you can't factorize, you can use a quadratic formula, right? Remember, if you have an equation like this, a x squared plus b x plus c equal to 0, then the quadratic formula would be x12 is equal to minus b plus or minus square root of b squared minus 4ac over 2a over 2a. And if we look at these two, if you compare this equation, you can simply tell that a is equal to 1, b is equal to minus 24, and c is equal to 80. So the next step, I will substitute this a, b, c here in this equation, and our x is equal to q. So this means we have q12 equals 24 plus or minus square root of 24 squared minus 4 times 1 times c, which is 80, over 2 times 1, right? And if you punch this in your calculator, you should have 24 plus or minus square root of 305 over 2, right? Okay. If you punch this in your calculator, first we put plus. Oh, this means our Q1 is equal to 24 plus 305 over 2. If our Q1 is this, you can use minus to find our Q2, because this is plus or minus. So this means we have 24 minus square root of 305 over 2, right? And if you punch this in your calculator, you should find Q1 equals to 20.73, right? And okay, this is approximately to 20. And if you punch this in your calculator, you should find 3.27, and this is approximate to 3. Okay, this means at break even, the firm therefore breaks even either at 3, at Q equals to 3, or at Q equals to 20 units of the good produced and sold. Okay. And again, you can find the points whereby the profits will be made. And you know that when the profits can only be made at when the total revenue is greater than the total cost. Okay, this is profits made. Okay, you can use this condition to find the points where the profits will be made. And then you can use this condition to find the points whereby the loss, okay, this is loss. Right, you can use this tool to determine where the profits will be made and where the loss would be made. Okay, for now I only find the points whereby the profits, or whereby let's break even. Okay, let's move on. Okay, our next section is the elasticity of demand for nonlinear demand function? Nonlinear demand functions. Okay, so far we've looked at the concepts of elasticity for linear demand function, right? And we said that the point elasticity of demand for linear functions is defined as E equals to the change in Q over the change in P times P over Q. And we said this is equal to minus 1 over B times P over Q. Okay, we said this is what we'll use to find the elasticity of demand for linear functions. Okay, now we want to find the elasticity of demand for nonlinear functions. Okay, for nonlinear function, we will use the derivatives, right? So if we use the derivative, so this means the elasticity of demand for nonlinear would be given as E equals to the derivative of Q with respect to P times the derivative of P with respect to Q. Okay. The trick is here. The derivative of the demand function, it would be sometimes be given as in the derivative of P with respect to Q, or the derivative of Q with respect to P. But you see in our equation, we need the derivative of Q with respect to P. So we just have to find the inverse of this, okay? Just use this trick. The derivative of Q with respect to, let's say you have the derivative of P with respect to Q. The derivative of Q with respect to P will equal to 1 over the derivative of P with respect to Q, right? Now, when you have determined the elasticity of demand, the next step is to determine whether the demand is elastic or inelastic. Okay, we have 4 cases to determine the elasticity. Okay, we have the case whereby the absolute of this elasticity is greater than 0, and when it's greater than 1, and when is less than 1, and when is equal to 1. Okay, here when the absolute of the elasticity is greater than 1, at that it's a given price, then that means the demand is elastic. And here, when it's less than 1, at that given price, any given price, then you set the demand is inelastic. And if it's equal to 0, you said we have elastic. Okay, if we have an elastic demand, as in case 1, then this simply means if the price increases by 1%, then the demand decreases by more than 1%. And for the second case where we have a demand, where we have an inelastic demand, okay, that case means if the price increases by 1%, then the demand decreases by less than 1%. And for here, the third case, means when the price increases by 1%, then the demand increases by 1%. Then the demand decreases by 1%. Okay, let's quickly do an example. Suppose we are given a demand function as in P equals to 100 minus 4Q squared, right? And we are asked to find the elasticity of demand. Okay, maybe elasticity of demand at different points. I want different points. Maybe at P equals 20, at P equals 90, and okay, at P equals 20, P equals 90, and P equals 200. We also find the elasticity of demand here on these points, 3 points. P equals 20, P equals 90, and P equals 200. We need to use our elasticity of demand formula. It says elasticity of demand is equal to the first derivative of Q with respect to P times the derivative times P over Q. Okay. From P is equal to 100 minus 4Q, we can since P is the function of Q, that means we can differentiate P with respect to Q. That means we can from P equals to 100 minus 4 Q squared. That means from this equation, we'll find the derivative of P with respect to Q, right? If we differentiate this equation with respect to Q, the derivative of 100 is a constant here. That means the derivative of 100 is 0. But the derivative of minus 4Q squared will give us minus 8Q, right? This is dP over dQ. And in our equation, we need dQ over dP, the derivative of Q with respect to P. But I said we can invert this and we can find the inverse of this. So if we have dP over Q, this means dQ over dP is equal to 1 over dP over dQ. And our dP over dQ is minus 8Q. So we can just take this and substitute it back here. So if we do that, we will find the elasticity of demand as in minus 1 over 8Q times P over Q, right? And we are given, we know that P is equal to 100 minus 4Q squared. We don't know what is Q. Then we still need to find Q, because we need to leave this equation in a form of P. So we need to solve for Q from this equation and substitute it back here. Okay, so let's do that. Let's do this. I want to make Q a subject of the formula. First, I will transpose 100 I'll transpose 4q squared to this side and p to this side. If I do that, I will have 4q squared equals 100 minus p, right? Remember, I don't want 4q squared. I want q. It's either q or q squared. Okay. Remember, this is minus p over 8 q squared because I have q times q, right? So this means from here, I can solve for q squared and substitute back here. Okay. I will divide by 4 on both sides. If I divide by 4 on both sides, I'll have q squared equal to 100 minus 4 minus p over 4. So I'll just take this and substitute back here. If I do that, I take that and substitute that here, I will have the elasticity of demand as in minus p over 8 times 100 minus p over 4. And if you simplify this further, you should get minus p over 2 times 100 minus p. This is what you will get as the elasticity of demand. Remember, we were asked to determine the elasticity of demand in 3 points. At P equals 20, P equals 90, P equals 200. Okay, first I will substitute P equals 20 here. Have elasticity of demand as in minus 20 over 2 times 100 minus 20. If you substitute this here, you should get, if you substitute this here, you should get minus 0.125. Remember, we have to look at the absolute value of the elasticity of demand. So this means the absolute value of the elasticity of demand, if, okay, we have the elasticity of demand as in minus 0.125. Okay. If the elasticity of demand is minus 0.125, that means the absolute value of minus 0.125 would be 0.125. And this value is less than 1. Since this value is less than 1, this means the demand is inelastic at this point. Okay, at the point P equals to 20. So this means we'll say, okay, we can say demand is inelastic at the price of 20 rand, right? Remember, we are asked to find the elasticity of demand in 3 points. The next point was when P equals to 90, right? We'll go back to our elasticity of demand function, which is P equals minus P over 2 into 100 minus P, right? Okay, we just substitute now